right, guys, I'm going to get started. Can I get a thumbs up at home that you hear me and see the board okay? All right, here we go. So, guys, last week we did square roots. Yesterday we did third roots. Today I'm going to try and mix in fourth and fifth roots. And then that's as high as I'm going to go. Tomorrow will either be a review or I'll let you guys just, my camera, okay. Thought my camera just went out on the presentation. Or I'll let you guys work on the homework, I'm not sure. But Friday you'll take a quiz on these nth root radicals on quizzes. It'll be 10 multiple choice questions, okay? All right, so here we go. Fourth roots. This is going to be our fourth root radical symbol. It's going to have a 4 tucked up into that little corner as your index or your root. So now you are unfourth powering something, okay? So guys, these are your perfect fourth powers. You'll find them in that fourth power or fourth root column of your chart. These are all numbers that you can take the fourth root of and get a whole number back. And clearly the list would keep on going. And then the key to the variables is going to be that if you take the fourth root of x to the fourth root and the power of 4 are canceling, and you are left with just x. So for each x to the fourth that you take the fourth root of, it will equal x, right? What can you times by itself 4 times that will equal x to the fourth? In x, okay? So that's what we're going to look for. We have to make groups of 4 when we're taking the fourth root of a variable. All right, guys, let's jump into the examples. Let's see how these ones work. I got to get my chart handy. All right. I'm going to go over to my chart, and I'm going to do the examples off to the side again so we can have our chart clear. All right, so example number 1 was, what is the fourth root of 625? Well, guys, go to your fourth root column, cross your fingers, and hope there's a 625 in this column. It's actually right there. Take it all the way to the left home. What number do you land on? And it's 5. The fourth root of 625 is 5. All right, and again, if you wanted to use your calculator, blank screen, put a 4 on the screen because we're going to be taking the fourth root. Go get that little square root symbol that has an X tucked up in the corner. Usually you have to press second and then another button, and then you enter in 625, hit enter, and it'll tell you 5. That's how you do it on your calculator. I'm trying to save you from having to do that. All right, let's go to the next example. If I asked you, what's the fourth root of 48? Well, the fourth root of 48, go to your fourth root column, look for 48, but there isn't one. We skipped right over it. We went from 16 to 81. That means that 48, it's not a number that you can take the fourth root of and get a whole number back. So maybe it's a simplified fourth root and it'll stay just like that. Otherwise, you have to look in your fourth root column and see if there is a number that will divide evenly into 48. You want the biggest one. Well, guys, in your fourth root column, it goes 1, 16, 81. All these numbers are too big. So either 16 is going to divide evenly into 48, or we can't do it. Does 16 divide evenly into 48? It does. So we can split this into the fourth root of 16 times the fourth root of what? 16 times what gets you 48? Who's the leftover? 3. All right, now you can go through and take the fourth root of whatever you can. The fourth root of 16, fourth root 16, take it all the way home, is 2. And then the fourth root of 3, guys, you can't take the fourth root of 3, nor does anything divide evenly into it because we don't count 1. So that's a simplified fourth root, and we leave it as the fourth root of 3. So 2 times the fourth root of 3 is how we simplify the fourth root of 48. All right, now yesterday we saw with odd roots that you could take the odd root of a negative number and not make an imaginary number come out. Fourth roots, guys, nothing times itself an even number of times should end up negative. So you cannot take the fourth root of a negative number and get a real number to come out. That would be imaginary. I don't think they make you practice the negatives with the fourth root, but just know a fourth root could create an imaginary number. All right, let's go to the next example. Now they ask you, oh, we're getting into the variables now? I think I can leave my chart then maybe. Okay, yeah, let's leave the chart. All right. All right, so we look at our notes. They want to know what's the fourth root of x to the fourth. That's our baby, right? If you're going to fourth root a fourth power, they cancel, and you're left with just x. For each x to the fourth that you can fourth root, you're going to leave yourself with an x. All right, so guys, if they asked you what's the fourth root of x to the 20th, you have to find out, well, how many x's to the fourth can you make from an x to the 20th? So instead of expanding all that out, you can just say, all right, it should be x to the power 20 divided by 4. Just 20 divided by 4? Yep, so it's good. It's going to be x to the 5th. That means you can make 5 x's to the 4th from an x to the 20th. And then each one of you, those that you fourth root, will create an x. X times itself 5 times is x to the 5th. All right, look here. The fourth root of x to the 7th. How many x's to the 4th can you make from an x to the 7th? Well, let's see. That should be x to the 7 divided by 4. Well, guys, does 7 divide by 4? No, so we don't want to write it like that yet. We don't want the fractional exponent. So we're going to have to break this up. What's the closest number to 7 without going over that divides by 4? 4. So we're going to have to break this up into the fourth root of x to the 4th times the fourth root of, well, how many x's are left over to get you back to 7? 3. All right, so now I can take the fourth root of x to the 4th. It's x. I can't take the fourth root of x to the 3rd. That's the leftover part. 3 doesn't divide by 4. Nothing smaller than 3 divides by 4. So he's going to stay stuck underneath that fourth root. So guys, remember, with 4s, every fourth number divides by 4. So you could have 1 left over, you could have 2 left over, or you could have 3 left over before you get to that fourth number that divides by 4 again. So you could have an x squared, or an x to the 3rd left over. Perfect. All right, look at this one, the fourth root of x to the 14th. Well, that should be how many x's to the 4th can I make from a 14? That'll be 14 divided by 4, but it doesn't divide. So we have to split it. What's the closest number to 14 without going over that divides by 4? 12. So we're going to break that up into the fourth root of x to the 12th, because I can take the fourth root of that, times the fourth root of x. How many are left over to get you back to 14? 2. All right, what is the fourth root of x to the 12th? Well, 12 divided by 4 is 3, so he's x to the 3rd. He's free, no more fourth root. I can't take the fourth root of x squared because 2 doesn't divide by 4. Nothing smaller than 2 divides by 4, so he's the leftover. He's going to be stuck underneath that fourth root. Okay, give me 1 second. BD3. Hey, Allie's attendance. I'll tell her. She's not in the room, but I'll tell her when she gets back. All right, bye. Okay. All right, so guys, that's how we do it. It's just like the square roots. It's just like the third roots, except when you're working with a power of 4, now you need your exponents to divide by 4, right? All right, let's look at a big problem now. If they ask you to take the fourth root of all of this, well, nothing's waiting on the outside this time, so that's nice. I think we should split all this. Since this is all attached by multiplication, let's put it under their own fourth root so we can deal with each piece one at a time. So it'll be the fourth root of 81 times the fourth root of x to the 4th, oh, I like that, the fourth root of y to the 7th, and then the fourth root of z to the 18th. And let's deal with each one at a time. All right, well, guys, the fourth root of 81. If you go to your chart, go to your fourth root column and cross your fingers, there's an 81. Holy crap, there is. That means you can take the fourth root of 81. You don't have to split him. He is a perfect fourth power. So I'm actually going to leave him alone. I'm going to leave him as is because I don't have to change him. I'm just not ready to take his fourth root yet. So the fourth root of 81. Can I take the fourth root of x to the 4th? Does 4 divide by 4? Yeah, so he's good. I don't got to fix him. I'm going to leave him. Can I take the fourth root of y to the 7th? Does 7 divide by 4? No. So let's see if we can split him. What's the closest number to 7 without going over that does divide by 4? 4. So I'll split him up into the fourth root of y to the 4th. And then the fourth root of how many y's are left over to get you back to 7? 4 and then 3. And then he's good. Go to the fourth root of z to the 18th. Does 18 divide by 4? No, so we're going to split him. What's the closest number to 18 without going over that divides by 4? 16. So we'll make that the fourth root of z to the 16th. And then the fourth root of z, how many z's are left over to get back to 18? 2. Woo! All right, so we did the hard part. Now it should be the fun part. We get to go back, take away the fourth roots that can go away, leave the ones that have to stay. So guys, the fourth root of 81 on your chart, who did it say that was? 3. All right, the fourth root of x to the fourth is just x. The fourth root of y to the fourth is just y. The fourth root of y to the third, remember, he was the leftover. 3 doesn't divide by 4, nothing smaller than does, so he's got to stay the fourth root of y to the third. I can't break that out. All right, the fourth root of z to the 16, 16 divided by 4 is 4, so that's z to the fourth. He's free. And then the fourth root of z squared, he's the leftover. I can't take the fourth root of z squared. 2 doesn't divide by 4. Nothing smaller than 2 divides by 4. That's the leftover. He's going to stay stuck underneath that fourth root. All right, clean up. Now we're going to multiply anything that's broken out, not under a fourth root anymore together, put it in front. Anything that is under a fourth root, we're going to multiply together and put it under 1/4 root. All right, so that's going to be 3 times x times y times z to the fourth. That's going to be 3x, y, z to the fourth. Done, 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 and done. And then it'll be the fourth root of, who's still under? Y to the third times z squared. And there's your simplified fourth root. All right? How do we feel about that? Are we okay? All right, let's look at this one. Number 8. Negative 3xy to the third, guys, that's just hanging out, waiting in front to be multiplied with anything that breaks out from underneath this fourth root. Let's separate them. I'm going to split them all. Since they're all attached by multiplication, I'm going to split them so I can think of them one at a time. Okay, so we got them all split. Let's go one by one. I'm going to bring down my negative 3xy to the third, and let's get to getting. All right, the fourth root of 1,250. If you go to your chart, fourth root, 1,250, looks like we jumped right over it. That means you can't take the fourth root of 1,250. Either he's already simplified and we're not going to touch him and he'll stay under the fourth root, or, guys, can you find the biggest number on this list that does divide evenly into him? 625. We can use 625 to simplify him. So we're going to split that into the fourth root of 625 times the fourth root of, well, 625 times what gets you 1,250? 2. Okay? The fourth root of x to the 12. Does 12 divide by 4? Yeah, guys, you can take the fourth root of that. I'm going to leave it for the next step. He's good to go. I don't have to change that. All right, the fourth root of y to the 25th. Does 25 divide by 4? No, so we're going to have to split him up. What's the closest number to 25 without going over that divides by 4? 24. So I'll break it up into the fourth root of y to the 24th times the fourth root of how many y's are left over to get back to 25? Just 1. And then the fourth root of z to the third. 3 does not divide by 4, and nothing smaller than 3 divides by 4. So guys, that's a simplified fourth root. We can't change him. He's just going to be stuck as the fourth root of z to the third. Okay, now we should be able to go through and take away our roots. So negative 3, xy to the third is still hanging out. All right, what was the fourth root of 625? That was 5, right? All right, the fourth root of 2, you can't take the fourth root of 2 and you can't simplify it. That's the leftover. He's going to stay stuck. All right, the fourth root of x to the 12. 12 divided by 4 is 3. So that's x to the third. He's free. No more fourth root radical. Y to the 24th. 24 divided by 4 is 6. That's y to the 6th. He's free. No more radical. I can't take the fourth root of y. He was the leftover, so he is going to stay stuck. And we already said you can't take the fourth root of z to the third, so he's going to stay stuck. All right, now we just multiply what's outside, and then we multiply what's under together. All right, outside, negative 3 times 5 were the only numbers. That's going to get us a negative 15. Now we'll do x's. X times an x to the third broke free. That's going to be x to the 1 plus 3 is 4. Done, done. Now we'll do our y's. Thanks, Zach, I appreciate it. Y to the third times y to the sixth is y to the 3 plus 6 is 9. They're done. And then nothing else is left. So I don't have any z's on the outside. So now I get to put everything that's under the fourth root radical back together. So that'll be the fourth root of, who's underneath? A 2 times a y times a z to the third. That's 2y z to the third. And you're done. How do we feel? Okay, again, it gets very repetitive. It's the same process over and over again. You just got to know who your root is. Whatever your root is, that's what you need your exponents to be divisible by. Okay? All right. Diego, okay. Here we go. All right, now guys, on the next page of your notes, now I want to show you fifth roots. All right, so guys, if you're going to work with fifth roots, I definitely want you to use your chart, use your fifth power and your fifth root column. All right, this is the fifth root symbol. He'll have a 5 tucked up in that corner as the index or the root. You are unfifth powering something. I've given you a list of some of your perfect fifth powers. These are the numbers that are in that column in your chart. These are the numbers that you will be able to take the fifth root of and get a whole number back. And then don't forget, if you take the fifth root of x to the fifth root and the power of 5 are canceling, and you're left with just x. So for each x to the fifth that you take the fifth root of, it will equal a just x. So now you have to figure out how many x's to the fifth you can make from your variables, which means they need to be divisible by 5. All right, let's give it a whirl. Guys, what's the fifth root of 7,776? Go to your chart. Now we're working with powers of 5 and fifth roots. Find your fifth root, look for 7,776, take it all the way home to the left, and it's 6. That means if you times 6 by itself 5 times, you will get 7,776. All right, what about the fifth root of negative 128? Guys, this means, can something be times by itself 5 times and end up negative? Absolutely. Remember, with an odd root, there are no imaginary roots. There is going to be an answer to this. So go to your fifth root column and cross your finger that there's a 128.
When you come to Marshalls again?
What's up?
When you come to Marshalls?
Oh, it won't be long, but I would say within the next 4 or 5 days. I'm there pretty often.
Okay, how come you never grab my discount card?
I don't know. Is there a thing like that?
Yeah, I can give you 10%.
Shut up. Don't tease me.
I'm not. I'm going to be transferring soon to HomeStat stuff.
Okay.
But also,
I go there too. I'll see you there. All right.
Do you know what the dude next over is?
Reynolds?
Or, yeah.
He's usually in there.
He's dead.
I have no idea. Yep. Oh, I get a discount, guys. This is so exciting. So you can get a negative root. That's fine. So the fifth root, I don't see 128. So guys, the fifth root of negative 128, can you find a number in this column that will divide evenly into it? Otherwise, it's already simplified. Guys, 32 will go. So we can split this into the fifth root of, give the negative sign to the perfect fifth power. So give it to the 32. And then the fifth root of, well, guys, 32 times what gets you negative 128? 4. All right? So then the fifth root of negative 32, well, what's the fifth root of 32? 2. So it couldn't possibly be a 2 that you times by itself 5 times that ended up negative. It must have been a negative 2. And then the fifth root of 4 is your leftover, and it stays. All right? Look at the next example. All right, now we're going to variables so I can go back to the notes. Are you guys okay? It's pretty repetitive, right? It's just the root is changing. Everybody at home okay still? We're all right? All right, hang in there, guys. All right, so now we go to this one. If they ask you to take the fifth root of x to the fifth, that's our baby. The fifth root and the fifth power will cancel, and we're left with just x. Every time you take the fifth root of an x to the fifth, you get an x. All right, what about the fifth root of x to the 10th? Well, how many x's to the fifth can you make from an x to the 10th? Because each one of them will create an x. So that should be x to the 10 divided by 5, 2. It's x squared. Because you can make 2 x's to the fifth from an x to the 10th. And then when you fifth root them, each one becomes an x. X times x is x squared. All right, we come here. The fifth root of x to the 6th. Well, that should be x to the power divided by root. 6 doesn't divide by 5, so we don't want to do that. Not yet. So now we can say, what's the closest number to 6 out going over that will divide by 5? 5. So we can split this into the fifth root of x to the fifth times the fifth root of how many x's are left over to get you back to 6? Just 1. But guys, remember, every fifth number divides by 5. So you can have 1 left over, 2 left over, 3 left over, or 4 left over. So you could have an x squared, x to the third, or an x to the fourth left over under a fifth root radical. All right, fifth root of x to the fifth, that's x, and then he's the leftover that stays, the fifth root of x. All right, the fifth root of x to the 19th. Well, how many x's to the fifth can you make from an x to the 19? Let's see. That should be x to the 19 divided by 5. That's a no-go. So what's the closest number to 19 without going over that divides by 5? 15. So we're going to split that into the fifth root of x to the 15th times the fifth root of x. How many x's are left over to get you back to the 19? 4. All right. So then the fifth root of x to the 15, 15 divided by 5 is 3. That's x to the third. The fifth root of x to the fourth, guys, we can't take them. That's the leftover. 4 doesn't divide by 5, so that'll stay the fifth root of x to the fourth. Okay? All right, let's look at let's try and do maybe one big one with the fifth root. All right? Let's go to the last one. I'll have that one filled in on your notes. It's probably a little bit easier. Let's go to number 8, and then we can stop there. All right, first I'd split it. Everything's attached by multiplication. Nothing's hanging out out front waiting to be joined. It's just, let's split them. The fourth root of 486 times I think I said fourth root, sorry, fifth root. The fifth root of x to the fourth. The fifth root of y to the 32. And the fifth root of z to the 15. All right, guys, the fifth root of 486. He's probably the hardest part. Let's go to our chart. Let's go to our fifth root. Let's look for 486. Damn it, there's no 486. So either he's going to stay the fifth root of 486 because he's already simplified, or can you find the biggest number on this list that divides evenly into him? Does one of these numbers divide evenly in? 243 will. 243 will. So let's use 243. So we'll split that into the fifth root of 243 times the fifth root of, well, 243 times what gets you 486? 2. All right? The fifth root of x to the fourth. Guys, 4 doesn't divide by 5, and nothing smaller than 4 divides by 5. So that's already a simplified fifth root. We're not going to be able to change that or fix that or break anything free. That's going to be forever stuck underneath that fifth root. All right, the fifth root of y to the 32. Does 32 divide by 5? No. So who's the closest number to 32 that divides by 5 without going over? 30. So we'll break that up into the fifth root of y to the 30th times the fifth root of y. How many y's are left over to get back to the 32? 2. And then the fifth root of z to the 15. Does 15 divide by 5? Yeah, so he's a perfect fifth power. I don't have to change him. I'm just gonna leave him as is, and I'll take his fifth root in the next step. All right, let's do this. Let's take away the fifth roots that can go away, leave the ones that have to stay. The fifth root of 243, guys, that was 3. All right, the fifth root of 2, that was the leftover. He is gonna be stuck under that fifth root. The fifth root of x, the fourth we said, is already stuck. He's already simplified. That is not something we're going to be able to fix or change. All right, the fifth root of y to the 30. 30 divided by 5 is 6, so that'll be y to the 6. He's free. No more fifth root radical. The fifth root of y squared, guys, he's the leftover. I'm not going to be able to get him out, right? 2 doesn't divide by 5. Nothing smaller does either. That's going to have to stay the fifth root of y squared. And then the fifth root of z to the 15, 15 divided by 5 is 3, so that's z to the third, and he's free. No more fifth root radical. All right, let's multiply what's not under together. So that would be a 3 times a y to the 6 times a z to the third. That's the only things that broke out. And now anything that's still under a fifth root, let's multiply it together and put it back. That's going to be 2 times x to the fourth times y squared. And you're done. Okay? All right. So guys, it really shouldn't matter at this point what root you're working with. You know how to handle them. You use your chart for your numbers, and you always need your exponent, your power, to be divisible by the root. All right? All right, guys, the homework tonight is actually much simpler than these examples. It's little problems like this on the fifth and the fourth roots, okay? They don't get too big on the Delta Math homework, so it should be something you can do pretty quickly, okay? All right, tomorrow, like I said, it'll either be a review or I'll just let you guys work on the homework if you haven't finished that yet. I haven't decided, and then Friday is a quiz. You are taking a quiz on Friday on these nth root radicals, okay? All right, let me double check the attendance, and then you guys will be good to go. As always, please let me know if you have any questions.